Hey guys, welcome to day 2 of lesson 821. We are going to delve a little deeper into these complex numbers and kind of see exactly like where they come from, what they actually even are. We didn't talk about that as much yesterday. Yesterday we had started out by solving an equation, and the solutions to that equation were not really real numbers, right? And so that's kind of what we're going to be focusing on today, is equations that don't have real solutions. So if we were to take this equation right over here, this is a quadratic equation, and if you remember our good friend, the quadratic formula, we can use that to figure out the solution to this if we were to set this equal to 0. So to remind you, the quadratic formula was opposite of b plus or minus the square root of, oops, not a 4. Just rewrite this whole thing. B squared minus 4 times a times c, all over 2a. Okay, hopefully you guys remember this from last semester, and if not, well, you can go back and watch old videos or, just relearn it. And to use this formula, we got to start by identifying our a, b, and c here. Remember, a is the number, or a is really the leading coefficient here, so since we don't have a number with that x squared, our a is going to be 1. Our b is going to be negative 4. It's always the one with the x. And then our c is going to be that plain old 5 on the end there. Alright, so now that we have selected my a, b, and c, I can go ahead and just plug those into my formula wherever I see fit. So let's see, we have a b right over there, so I will go ahead and write my negative 4 in. Trying to keep this color coded. Plus or minus the square root of, that square root's a little messed up, but we're going to go with it, b squared minus 4 times a times c all over 2 times a. Alright, so now that we have plugged everything into that formula, this is where we get to sit here and just simplify. Now this is where you gotta take your time, don't be hasty. This is where there's the most room for error. So just piece by piece, simplify whatever you can. Here, for example, we have a negative 1 times a negative 4, and that's ultimately going to give us a positive 4. And that's why when we say the formula, like verbally, we typically say opposite of b. So like whatever my b was, what you end up with here is going to be the opposite sign. So since my b was negative, we have a positive. So plus or minus the square root of, negative 4 squared is going to be 16, and negative 4 times 5 times 1 is going to be negative 20. Okay, all over 2 times 1, which is just 2. Now this is starting to look better, but we can simplify even more. We know that 16 minus 20 is negative 4, so we'll replace that inside. Okay, now it's looking even better, but we can go even farther. Okay, so remember, yesterday we talked about how to simplify these square roots when there's negative numbers in them, so I'm going to do a little side work over here to just refresh you on that. So when you have the square root of negative 4, you can rewrite that as the square root of 4 times negative 1, right? And then you can rewrite that again as square root of 4 times the square root of negative 1. That's just how radicals work. So now square root of 4 you know is 2, square root of negative 1, we learned that that's called I. So square root of negative 4 can be simplified to 2i. So that's what we'll use there. So this can simplify to 4 plus or minus 2i over 2. Now we're really close to being done. This looks a lot better than that mess we started with, but we can go a little further. So you hopefully noticed that both the 4 and the 2 up here are divisible by 2, so we'll go ahead and do that and divide them by 2. So 4 divided by 2 gives us a 2, 2i divided by 2 gives us a 1i, so I'm just going to write I there. So we're pretty much done here. So basically our two roots are going to be 2 plus I and 2 minus I. And we're going to talk a little bit about what this means in this next section here, but this is how you use the quadratic formula to find your two roots. Something I do want to point out that does show up on my open math, so I want to make sure I talk about it, is like the format of imaginary numbers, right? So if you look at how I have written this 2 plus I, 2 minus I thing, it's kind of in this like A plus BI format, where A is just some regular number and B is the number that's like basically the coefficient with the I. So in 2 plus I, for example, the A is going to be 2 and the B is going to be 1. Now the B is 1 because there's no number in front of I. If there was a number, then it would just be that number, but since there's nothing, there's just an imaginary 1. Alright, so this is just the typical format in which complex numbers are written. Okay, moving on here. So this is going to explain really what these imaginary numbers even are, what their purpose is. So, you know, when I ask you about roots, like if I asked you to look at this graph and tell me what the roots are, you would probably pretty easily tell me that they're just -5 and -1. Because roots are the numbers on the x-axis where our graph touches. So -5 and -1. Right? If you look at this one, we only touch once, so our roots, really we only have -3 to work with. But -3 is a root where we are bouncing off the axis, and if you guys remember from last week that when we bounce off the axis, that's a double root. So this -3 serves as both of our roots there because that -3 factor gets squared. So there's 2 of them. And whatever our degree is, that's how many roots we need. So since these are quadratics, all of these have to have 2 roots, no matter what. It's just that sometimes this one number can serve as both if it's a double. All right. So over here, now this is where the problems begin, right? I tell you to tell me the roots of this graph, and you're going to be like, well, what the heck? This doesn't even touch the x-axis. And that's exactly where imaginary numbers come in. No matter what, we have to have 2 roots. Every single second degree equation has to have 2 roots. And here, we don't even touch the axis. And so our roots are complex roots. That's where we have imaginary numbers. So like up here, this is an example of an equation for a parabola that does not touch the x-axis, which is why it had 2 imaginary roots. This is like kind of what it would look like for a graph like this. All right. So let's go through another example of quadratic formula. I don't think I'll have enough time in my recording thing to do all of these, but let's begin. So if I have x squared minus x plus 1, we start by labeling a, b, and c. So we have, now I'll just save from the color coding this time. So our a is going to be 1 because there's no number again. Our b is going to be -1 because there's a minus sign, but there's no number, so that's where the -1 comes from. C is going to be +1. Lots of ones. So if we go ahead and plug into this formula, we can say, okay, well, negative sign my b plus or minus b squared, so -1 squared minus 4 times my a times my c. It's nice we're working with such easy numbers in this problem. Okay, all over 2 times my a. So let's go ahead and simplify. This turns into +1. In the square root, we have -1 squared is just 1. -4 times 1 times 1 is just -4. All right, 2 times 1 is 2. So now we have 1 plus or minus the square root of -3 over 2. Now, -3 square root, this can be simplified with an I. It's just not one of those perfect square ones. So here's how we simplify that. We still have an I to pull out, but we keep this 3 in the square root because it's not a perfect square, and that's okay. All right, so basically these are our 2 roots, and if you wanted to write them separately, you would write 1 plus I root 3 over 2, and the other one would be 1 minus I root 3 over 2. Okay, and these are my roots. Okay, let's do the next one. Let's see if we can get them all done. All right, A, B, and C. This one has an A of 1, B of 6, and C of 25. So again, let's see if I can have that up there, just so you guys can see. So plugging into my formula, we have negative sign, my B, plus or minus the square root of my B squared minus 4 times A times C, all over 2 times my A. Okay, we've plugged into the formula, and now we're ready to simplify. So negative 6 plus or minus the square root. 6 squared is 36. Negative 4 times 1 times 25, that's going to be negative 100. 2 times 1 is 2. All right, so we have here negative 6 plus or minus the square root of 64. Negative 64. 36 minus 100 is negative 64 over 2. So now we can simplify this, and that would actually be an 8i here. Remember what we did in the very first problem, right? The square root of negative 64 turns into the square root of 64 and negative 1, which then turns into this, which becomes, oops, it's not really. There we go. All right, so that's where that 8i comes from. So we have negative 6 plus or minus 8i over 2. Now these two actually can be divided by 2, so we can simplify this even more to negative 3 plus or minus 4i. Okay, so this is pretty good. If you want to write it as my separate answers, we would have negative 3 plus 4i and negative 3 minus 4i. These are my roots. It's kind of ugly, but it's fine. All right, we got one more here. Let's see if we can do this. Now, something like this, you don't want to let this confuse you. We don't have an x term, like a middle term like we do in these other examples, but that's okay. We can rewrite this equation to look like something we're more familiar with. So we could just, since there's no x term, we could just put a 0x there. So that's the same thing since it's 0. And now it looks just like we're used to. So we have our A is going to be positive 3, B is going to be 0, and C is going to be 48. All right, so let's go ahead and plug into our formula. It is, we have opposite of B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. Okay, so let's simplify this. This negative 0 is just 0. And then in my square root, I have 0 minus 576 all over 2 times 3 is 6. Now let's bring this up over here. Now we, at this point, we don't even need that plus or minus anymore. Basically, we have a, well, actually, we could just leave it. 0 plus or minus. Now in these square root, we have negative 576, and then we have a 6 down here. Now, negative 576, we can simplify. The square root of 576 is 24, so really, we have positive or negative 24i over 6. Okay, so my roots then are going to be, well, and we can simplify this really, so this becomes positive or negative 4i. 4i and negative 4i. Those are my roots. All right, almost out of recording time here, guys, so I'm going to go ahead and work these out, and then I will unpause. I'll pause recording, work them out, and then unpause it so you guys can see the solutions. All right, I've worked these all out. This is a pretty basic one. This is going off of the same stuff we did up here in the quadratic formula examples, just to practice simplifying once you get to that point. Same thing here. This I just want to really point out that, take this step by step and write everything out so you can see. Notice how I kept this I squared as it was to just make it easier for myself to see the answer.